sort of come back to, so, you study birds, but this does have implications for humans and the evolution of human brains. How do you see work on animal cognition and animal brains as kind of feeding back into the human cognitive sciences?
Yeah, well, when we were doing our bird work without looking at humans, we're publishing work on birds and finding interesting convergent findings amongst different bird species. And I was expecting somebody who studies humans to take up our work and try to replicate it and see it's going on in humans, and it wasn't happening. So I decided to do that ourselves, in collaboration with the Allen Brain Institute and others, where we got human samples, postmortem human samples, and we found some of the same genes are convergent in humans as in these birds, which means that our mechanism of evolution of speech is not that different. There are differences, but it's not as different as some would like to think in the cognitive world as what we find in these birds. And there are differences of degree. We're obviously a lot more advanced in our abilities for vocal communication behavior, but there's a lot of overlap that people get surprised about. Mm-hmm. And so that allows you that, and it's not just the mechanisms of the behavior itself or the underlying genes that are changing that are similar, right? But it's when those genes have mutations in them in humans, causes speech deficits, we can study those same mutations in birds, all right? And have some similar deficits as well. So the disorders of the trait are also convergent, if you want to call it that. And so that, in answer to your question, yes, we can translate those findings from birds to humans because of the convergence.
And are we going to be able to do things like CRISPR-Cas knock-in of human mutant genes, like what's been done with mice? Are we going to be able to do that with birds in the next?
I think so. Yes. So we're working on creating transgenic birds using CRISPR technology, and it's been hard. It's not as simple as, well, never simple, but there was a lot of work that went into doing this in mice and Drosophila. But I think we'll get there. And to be able to put in these, human mutations and genes like FOXP1 or FOXP2 and SLIT and ROBO and so forth into the birds and find out what's going on. I think that'll happen in our lifetime.